Welcome back. So, as we get into chapter 11 now, we're going to be talking about something called power series. But let me first, before we get to power series, uh, let's first kind of retrace our journey. So, back in Calculus 1, you learned about doing integrals by setting up sums. And so, this was actually your first experience with infinite series, although we typically didn't write it that way. So, but just to kind of recall briefly, right, we set up our sum, right, a long time ago before we had the fundamental theorem of calculus, right, we would set up our sum by figuring out the width of our intervals, right, figuring out our values, putting them into our function, and times delta x. And at the time, we were dealing with sums as we go from 1 to n. We didn't introduce the idea of infinity because we had some formulas that let us, eventually take that thing, sum of something involving I, right, and simplify it down to some expression involving n, which we were then able to then take the limit of that expression. Okay. So those were the kind of sums that we were working with, sums that we were able to talk about, formulas for things, and to be able to compute. And we then transitioned, that's what you did in Calculus 1. And then we then started exploring infinite series. And one of the things we talked about specifically was the geometric series, right? Which, as we discovered, only converges if the ratio is less than 1, right? It's less than 1. And so when that is less than 1, we took the limit of that stuff. And it turned out the limit of that stuff just became a over 1 minus r. So that was the geometric series that we talked about. And so we were able to say that the sum of that stuff is a over 1 minus r. Okay, so that's what we moved on to. And then we talked about different types of series. And we have lots of rules now for testing convergence of series. Well, now what we're going to do here when we come into the idea of power series is we say, now, if we take a sum as k goes from 0 to infinity of c sub k, x to the k, right, which would just be equal to c0 plus c1x plus c2x squared plus c3x cubed, and so on forever. Eventually you'd have cnx to the n, right? And this would keep going on forever. In other words, we have this infinite polynomial. So that series, which is now a polynomial on the variable x, an infinite polynomial, where ck is a sequence where ck is a sequence is called power series. And so what we're going to talk about in this chapter 11, is this infinite polynomial, which for some values of x will actually converge to an actual function, an actual closed function. Like, for example, there's an infinite polynomial that we can write that would actually always converge to the sine function, or the e to the x function, or the cosine function. Okay, so this is called power series. And so what we're going to be looking at is, for different times, what values of x would this thing actually produce, correct results, and would the infinite series actually converge? And it turns out there's some, again, that will converge for all real numbers. There's going to be some that will converge for a limited range of values. And then there's going to be some that will only converge if x is at 0. If x is 0. That would be the only time that they converge. Okay, so that's called power series. So we're going to be dealing with that. Before we get into power series, though, we're going to be building up. And looking at polynomials. The first topic we're going to talk about are what are called Taylor and Maclaurin polynomials. And these are polynomials that are going to follow a certain pattern. And then if we let that pattern go off to infinity, then we produce a power series. So that's what we're going to be talking about here in the upcoming section. First section, we're going to talk about polynomials, and again, the idea of expanding that to get on to infinity to produce a power series. And so then in the second section, we'll talk about power series in general, and then we'll come back and talk about expanding these polynomials that we've been looking at, expanding these polynomials that we've been looking at to produce infinite series. And again, the big question is going to be, what's this infinite series equal to? And then also, what does it converge to? When does it converge? For what values of x does it converge? Okay, so that's kind of the introduction. We're going to be getting into this more in the upcoming video.